for different applications. Now, I was talking yesterday about the terminologies used in this subject, sensors and transducers, which will be interchangeably used. Detector is rarely used, which detects only presence or absence of an object. And a pickup is essentially a transducer which is excited by AC. Pickup is actually a transducer which is excited by alternating current or alternating voltage. So a capacitive transducer or an inductive transducer is essentially called a pickup. So a capacitive transducer is open for DC signal because of the no connectivity at the parallel plates. There is a dielectric between the two parallel plates of a capacitor, and therefore it is responsive only to the DC signal, and it acts as a short for DC. As the frequency of the AC, it acts a short for AC, and as the frequency of AC signal increases, the conductivity between plates increases because of the alternating. That is the property of a capacitive transducer, and that property is exploited for certain applications which we shall see. And inductive transducers also require alternating current for various applications. Now, sensor essentially gives a mechanical output for a mechanical input. So if you consider spring, the mechanical force applied on the spring generates displacement of the spring. If you have a pointer at the tip or the middle of the spring, the displacement can be read by the pointer moving on a scale. So the force can be calibrated in terms of displacement on a scale, and the scale can be calibrated to indicate the force. So essentially, a transducer converts a mechanical or physical variable into a electrical quantity. What are the advantages of electrical signal? Why should we convert essentially to electrical signal? We shall look into them because of the additivity property. We can add two electrical signals. We can have a product, mathematical operations of the electrical signals. We can take a difference between two signals using a subtractor circuit. Using a summing amplifier, we can add two electrical signals. We can have products. We can have quotient of two signals. So all these mathematical operations are possible. It is flexible. We can transmit electrical signals from one place to another place wirelessly in a wired manner, or whatever the manner that you can design for. Now, these are not possible with mechanical gadgets. Electrical systems have few more advantages which we shall see later on. So, transducers means electrical transducers, which means that they give electrical output. Sensors give mechanical output like displacement or velocity or acceleration can be sensed and then provide a suitable output. And the detector just detects the presence or absence of an object, and pickup is essentially a set of transducers like capacitive and inductive transducers which require alternating current excitation for their operation. Okay, now some sensors we shall see for clarity purpose. Spring converts force to or the torque input into a displacement signal, as I mentioned. Do you know what is a diaphragm? A diaphragm is an elastic membrane in a microphone which vibrates. Now, a diaphragm is an element in a piston cylinder gadget. Now, bellows, I should have put some diagrams. If you can imagine the buses with air suspension. Nowadays, buses, luxury buses, will be mounted on bellows. Instead of just shock absorbers, they will be mounted on bellows which can collapse. Those are all metallo-elastic membranes which will collapse or expand. as the case may be, depending on the vibration on the road, or the obstacles, or the humps and dumps, or the potholes on the road, the buses will oscillate vertically. So, not to act as shock absorbers, bellows are used. Now, board-on tube. What is a board-on tube? I have a diagram here. Just a provide member on the right is a board-on tube. If you apply a pressure signal at the bottom, the other end called strain gauge sensors, which are mounted on load cells. There are different types of load cells, column type, and then so many other types are there. The column type of load cell with strain gauges, 4 strain gauges mounted on each column type of load cell will be below the platform where the truck is parked, and then it will be transduced into an information regarding weight. Now the whole weight minus the weight of the lorry, that is called tare weight without load. What is the weight of the truck subtracted, and if the load is within permissible limits, allowed. If not, they are fined. So that is very, very important sensor, strain gauge, and the load cells. So they will provide resistance change at the output. So I will show a few slides with the diagrams there, and you can see them. And these are the inductive, capacitive, electronic, piezoelectric, photoelectric sensors. All these provide different electrical parameter change at their output. These sensors get the physical variable change converted into an electrical change. Now, a transducer has a primary sensing element and a transduction element. 2 stages are there. Input signal from the physical medium will be obtained, and that will be sensed, and a mechanical output will come. The mechanical output of the primary sensing element or the primary detector transducer, like meaningful output you get. So the primary functions of the detector transducer stage of a measurement system are first to sense the measurand point in a trans properly. The input signal is called the measurand in instrumentation terminology. So input signal is nothing but a parameter of the physical medium, where either I am sensing temperature or pressure or flow or level, or it may be displacement. I will be sensing these measurands like flow, level, pressure, temperature, and converting into a displacement or whatever signal by the primary sensor, which will be again in the second stage converted into an equivalent electrical signal. So sense the measurand properly. The primary detector transducer stage will sense the measurand properly. Am I audible? Is it okay? I just want to check.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Any feedback, please? Are you able to understand what I am telling? Or any improvement is required? Kindly be frank and free to express your requirements, please, because you are invisible to me.
No, sir, it's proper.
Is it okay? Thank you so much.
Yes, sir.
Understood.
Okay, let me proceed. The second point that is discussed below the diagram is that the second part, the secondary transducer part, or the transduction unit that is called, converts the measurand to a format acceptable by the intermediate stage. Or no, the actually 2 functions of the primary detector element they are telling. The first is sensing, the second is conversion of the measurand to a format acceptable to the intermediate stage of the measurement system. The next is the signal conditioning stage. So these are the 2 stages where a transducer will work. First part is the sensing, second part is the transduction or conversion of one form of energy to electrical form. So that is the essential part. Now, if you observe here how a mechanical quantity is converted into an electrical quantity, the pressure signal on the right bottom of a board-on tube, that question mark type of element that is shown, the board-on tube is a sensor, not a transducer. So a sensor and a converter will together form a transducer. Sensor, sensing and transduction will form a transducer, what we said. So the board-on tube converts the incoming pressure signal from the bottom of the tube. At the bottom, the air pressure, that means air under pressure, is allowed inside the tube, which expands the question mark portion on the top, and it will rotate up. So it will expand, the board-on tube expands angularly, and that is by pulley and gearing mechanism will be connected to the core, which is not visible. Inside that coil tube, there is an element which moves, a dielectric element which moves, which will be a coupling between the primary coil in the center of the tube to outer secondary coils. This is an LVDT, linear variable differential transformer, which we will be studying later under inductive transducers. So mechanical displacement of the core inside the tube, where secondary, top and bottom secondary coils, secondary coil 1 and secondary winding 2, so will be sensing with respect to the primary winding, which is getting an excitation voltage, alternating current. Therefore, this LVDT is a pickup, not a transducer. It can be appropriately called a pickup. Now here, the core of the LVDT will move depending on the expansion and contraction of the board-on tube, depending on the on the pressure that is inputted. If the pressure is high, the board-on tube expands angularly, and therefore the pulley is pulled. That is, not the pulley, the thread on the pulley is pulled because of the expansion of the board-on tube, and the core is moved up the tube. There is a dielectric material, or it is a magnetic material essentially, which is moving, coupling the primary coils and the secondary coils. If the core inside the LVDT moves up, then the primary coil at the middle, which is excited by the AC on the right, and the upper coil are coupled more compared to the primary coil and the bottom secondary coil. Therefore, there will be more voltage on the secondary 1 output than the secondary 2 output. There is a differential transformer action that will be taking place. Therefore, it is called a linearly variable differential transformer. There is transformer action taking place. Primary and secondary coils are available like a transformer, and that transformer concept is exploited to sense and convert into electrical signal, which can be transmitted, which can be signal conditioned, which can be amplified or attenuated, which can be filtered, etc. All this processing can take place in the electrical domain, which is not possible in mechanical domain. It is difficult, but it is not very impossible, but it is easy and versatile. Therefore, all the pressure signal is converted into, with pressure variations are converted into mechanical angular displacement variations by the board-on tube, which will be transduced appropriately by the LVDT, linear variable differential transformer, and that will be providing a differential alternating current voltage, and at a load point you can get an equivalent voltage proportional to the input pressure. So now, yesterday I had put this slide just to recollect. I am putting how to distinguish between a sensor and a transducer. A sensor gets a mechanical input and provides a mechanical output, or mechanical or thermal or chemical or magnetic or radiant. That means essentially a sensor provides a non-electrical output, whereas transducer provides a electrical output proportional to the physical variable or the measurand. We will be using the term measurand, which is nothing but the parameter that is being measured from the input medium. So you please go through this. I will be sharing these slides to you by today evening, or tomorrow I will share all the e-materials so that you can go through and be prepared and enjoy the material if you want to. And I'll also provide you the links in the YouTube wherein you can see and refresh yourself about the knowledge of these sensors, transducers, their applications, etc. Now, which are the electrical transducers which we will be studying in our syllabus? Some of them we are studying temperature transducers. There are many temperature transducers in the syllabus, but we are essentially studying in detail the RTD, thermistor, and thermocouple. So in the laboratories or wherever possible, we can demonstrate these transducers. When to use which transducer is an art, for which we need to know how to read specification sheets or the specs of these devices. So there are IC temperature sensors like AD590 and LM35, which are indicated at the top right. So yesterday I was telling AD590 will provide. Was I available then when I was discussing the AD590 or LM35, or I was off? Hello, my dear, one of you.
You are off, sir.
Probably off, sir.
Oh, you have not heard of this AD590 or LM35?
No, sir.
Okay. Let me repeat the story again then. AD590 is Analog Devices Company's IC. This IC is manufactured by Analog Devices, USA. So this transducer provides a current output in microamperes. It is a highly sensitive temperature transducer. It senses the temperature and provides electrical current as the output. Therefore, it can be called as a transducer because it is giving an electrical output. And the output current is proportional to absolute value of temperature, not the centigrade temperature or the Fahrenheit temperature. So the output current will be, if it is 27 degrees, let us say, if it is 27 degrees, room temperature is 27 degrees, AD590 will provide 300 microamperes current. Why 300 microamperes for 27 degrees centigrade temperature? Because 27 plus 273 is 300. It adds the absolute value, scale value, and provides the current which is essentially required for certain applications in industry wherein the absolute value of temperature is required. Therefore, they have designed this using what is called a current mirror concept. We see our face in the mirror, we see our body in the mirror. Using mirror, we can see the rear, we can have a rear view in the car or in the vehicle, rear view mirrors. We are having this current mirror in this AD590. They're inquisitive to know more about what is current mirror concept that has been used in AD590. Kindly go through the literature. You can Google and then find out. A very interesting concept, which is used to convert the absolute, that is centigrade temperature value, into absolute current value in microamperes. That is about the AD590. And then LM35, let me show you. AD590 will be appearing like this. Just 3 terminals. Supply, ground, and then the input temperature signal. And you can get the output. Now here, LM35 is a voltage output device. It will provide an output between 3 and 5.5 volts. No, sorry, 3 to 5.5 volts is the supply voltage, and the ground is the third terminal. Middle terminal is the analog output. Similarly, we have 1 output and 2 supply points. Okay, and here, what is a thermocouple? Thermocouple is based on Peltier effect or Seebeck effect or Johnson effect. So 2 metallic conductors of different electropositive and electronegative polarity will be combined, fused at one end. At a high temperature, the 2 metals are fused, means they become one. And that is available at the tip of this tube. At the bottom tip of this tube, the junction of the 2 metals will be available, which are fused. And as the ambient temperature and the medium temperature, let us say I am inserting this in a water bath of 500 degrees centigrade. So pertaining to the temperature difference, it will provide the temperature difference. It is with respect to the ice temperature. The reference temperature usually adopted in thermocouple temperature measurement is 0 degrees centigrade ice temperature. Reference temperature is ice temperature, and the difference between the actual temperature in the medium 500 degrees and this 0 degrees reference temperature, a proportional electrical signal will be provided by the Peltier effect or the Seebeck effect of the thermocouple, and you can get an electrical signal at the terminals pertaining to difference in temperature between 500 degrees and reference 0 degrees, and that can be further signal conditioned to get a meaningful output pertaining to the temperature. Thermistor is another sensor which is made up of semiconductor. The maximum temperature you can measure is 200 degrees only. After 200 degrees, it will lose its property as a semiconductor. Any silicon or germanium-based temperature sensor is designed to work up to 200 degrees. Semiconductor materials lose their value as materials beyond 200 degrees. Therefore, up to 200 degrees, you can easily measure linearly. Not linearly. It is the most non-linear transducer that we have among the different temperatures transducers that we come across. So it is having negative temperature. That is what it says, 10 kilo ohm minus NTC thermistor. NTC means negative temperature coefficient. It is having negative temperature coefficient. As the temperature increases, the resistance of the thermistor decreases. It decreases non-linearly, exponentially, because temperature is increasing and the resistance at the output of the device 103 is decreasing. What is 103? It is 10 power 3, that is 10 kilo ohm. That is the code that is used for the thermistor, and therefore it is a highly nonlinear device used extensively in control applications to sense the situation in the thermal environment. Did I share with you the application which I saw in an industry where I was working, wherein the thermistor sensors are essentially used in apnea monitors. Did I mention this yesterday? Apnea monitors? Please?
No, sir.
What is apnea? What is apnea condition? In the hospital, babies are born prematurely, 6th month, 7th month, 8th month. Now, these babies, which will be struggling to exist in this world as they get into the world from the mother's womb, they require support, which the mother externally cannot give to their species. For the preservation of the species, premature baby incubators are the engineering solutions provided. Premature baby incubators are nothing, you might have seen premature baby incubators in the hospitals. So there it is a thermal environment where baby is kept on a soft bed, and then lot of tubes, pipes and wiring, everything will be there on the baby to monitor its condition. Now, when the temperature in the incubator has to be a little higher than the ambient temperature for the sustenance of the life of the baby, premature baby, which requires extra warmth, which can be provided by the mother, but this premature baby incubator will provide all that without any infection. So it is an inert environment for the baby to be preserved without infection of the skin or whatever it is. So even though the temperature is provided, everything is okay, oxygen is provided, humidity is maintained, pressure inside the incubator is maintained, but still suddenly the baby stops breathing. As the baby stops breathing, it is called apnea condition. It's an emergency. How to know the baby is breathing or stopped breathing? When hundreds of babies are in the baby ward, a baby's ward is there in a hospital where all the babies are monitored by the nurses. how many babies a nurse can monitor when 2 or 3 babies are in emergency? So these engineering monitors, engineering solutions are provided wherein the moment the baby stops breathing, the body temperature of the baby goes down. The thermistor, as shown in this diagram 103, is mounted, not this one, a similar thermistor will be mounted on the premature baby. A small element, a micro element of a thermistor, will be mounted on the chest of the baby, which will be monitoring the skin temperature of the baby. As the baby expands and contracts the chest of the baby, so that will be monitored as the baby stops breathing because of the apnea condition. What happens? The body temperature, skin temperature goes down. Once it goes below certain level, an alarm goes on. The circuit is designed so that if the temperature goes below certain level, immediately the thermistor's resistance will increase as the temperature goes down. It's a negative temperature coefficient resistance. As the resistance goes up, the voltage drop increases because for the same current, more resistance, IR drop will be more, and you will get a alarm signal. The nurse will be immediately attracted, or the doctor will come and attend to the baby, and then artificial respiration, whatnot, the further procedures. The indication of emergency is very vital for the safety of the life of the baby. So this is a very vital transducer used extensively in industries for sensing, measuring, and then knowing the physical condition of many processes, and it is a very sensitive transducer. The most extensively used transducer, which is a standard among all other transducers because it is made up of a noble metal called, what is the noble metal used? What may be the noble metal used here? The commercial name of RTD is PT100, platinum 100. Why it is 100? Because at 0 degrees, platinum will show 100 ohms at its output terminals. How many number of times you go below 0 and above 1000 and then come back to 0 degrees? At 0 degrees, platinum will exactly show 100 ohm. That is why it is called a noble metal. The stability is important, repeatability is important, and resolution is important. RTD is a wonderful transducer, which is whatever RTD says, everybody believes. Whatever other transducer indicates, they doubt and refer to the standard transducer, that is RTD, where if RTD says something, they believe. So RTD is a standard, and depending on the temperature variation, output resistance varies positively with a positive temperature coefficient of resistance. Because it is made up of noble metal, metals have positive temperature coefficient of resistance, and therefore RTD is a wonderful sensor with sensitivity, stability. It is extensively used up to 100 degrees, 1000 degrees. From minus 150 degrees to 1000 degrees, it can give a linear output. And this thermocouple is used up to 1100 to 200 degrees, up to minus 150 degrees, because this is also made up of metal combinations, whereas thermistor is capable of measuring only up to 200 degrees. Very important information. So the LM35 is a voltage output sensor. 8590 is a current output sensor. Thermocouple is an electrical output voltage output sensor. Thermistor gives output resistance variation inversely to temperature. RTD provides a positive temperature variation. So these are the various transducers, thermal transducers, which I just listed them for introductory discussion, so that the importance of these transducers in our everyday life, in our profession, in industries, are very essential. Now, these are the many industrially used, extensively used transducers, which are used in home automation also. Most of your seniors will be using these transducers in their projects. I just wanted to show you these various sensors which are used. Sensor is a misnomer here. It is an electrical output device. Therefore, they may be called as transducers, even though the sensor part is mechanically outputted device. So now, what is the design the transducer, if it is connected to a physical medium, it should not load the system. It should convert the signal information into an equivalent electrical information. It reads, the function of the transducer is to sense the information and convert it into a convenient form for acceptance by the later stages of instrumentation system. That is first point. Convenient form, into a convenient form, that is electrical information. That is, conversion means transduction of input signal or information from one form to another requires energy. Whatever work has to be done, that is conversion part, requires energy. Some transducers generate their own energy. They are called active transducers. Some transducers need supply of external energy for transduction, conversion of energy to take place. So this energy may be extracted from the signal itself, like thermocouple. He is a active transducer. It doesn't require an external DC or AC power supply to convert the temperature information into electrical information. Therefore, it is called an active transducer, whereas RTD requires external power supply to flow a current through the resistive element so that you get a voltage drop. So there are different types of transducers which we will be studying. This energy may be extracted from the signal, thereby causing loading effects. If the thermocouple is extracting information from the measurand, the input signal, then it may load. We have to be careful. So to avoid this, to prevent this happening, without corrupting the input information, we have to get an output. How to do that? Thus, if energy is extracted from the signal, it will not be faithfully reproduced after conversion, which leads to errors. So without error, if you want to get, you have to supply energy. In fact, effort should be made to supply energy required by the transducer from an external source for conversion, so that the input signal is converted into an usable output without drawing an undue amount of energy from it. It has to draw energy from the supply, power supply, not from the signal, that is measurand, that is coming at its. The ideal conversion is when absolutely no energy is extracted from the signal. So that's about the design considerations. How to design a transducer without affecting the input information, how to get a equivalent electrical information. Now, this is just a block diagram of a smart sensor. As the syllabus title says, smart sensor, a sensor with a microprocessor or a microcontroller inbuilt, a computer inbuilt into a sensor IC is called a smart sensor. The sensor gives an analog signal, which will be signal conditioned using an ADC, amplified, filtered, all those things take place in the signal conditioning unit. Then an A to D converter, analog to digital converter, will convert that into a digital format, which the DSP chip or the microcontroller will process that information and provide a digital output, as shown by the parallel lines at the output of the digital signal processor at the center of the diagram. And that is converted back into analog signal. Digital to analog converter provides that, which will be interfaced to the real world devices which can understand only analog signals but not the digital signals. Now this digital signal can be interfaced to further devices and many control functions, digital controllers to operate discrete devices can take place, analog interface to trigger an alarm or etc., or some signal conditioning units require the bias or configuration or to remove the loading effect. For all these operations, at the top we have the voltage reference as a reference for the conversion to take place from sensing part to electrical signal, analog signal to digital signal, digital to analog signal at the DAC, and for transmission, all these require electrical powering, and then there must be some reference standard with which we have to function so that there is uniformity throughout the instrumentation system which is measuring the temperature, pressure, acceleration, position, magnetic field, or radiation, or any such parameter. So now, as you have seen in the first slide of today's talk, car sensors, the sensors used in a modern car. Nearly I have listed 25 sensors. Which are the 25 sensors that you may think of? One is testing the rotational speed of each wheel, measuring the position of the seats. So a driver requires a particular seat orientation, backrest, and the position of the seat with respect to the steering wheels. All these can be automatically adjusted depending on the person. The programming can be done. It's a Robert Bosch company's patent, wherein the automatic seat adjustment takes place depending on the person. Tire pressure sensor, atmospheric pressure sensor, high pressure sensor in the car, oxygen sensor, tank pressure, petrol tank pressure sensor, accelerator, pedal sensor, and then angle of rotation and position sensor, yaw rate sensor. If he is actually moving zigzag on a road, if the driver is driving the vehicle erratically, it will be sensed and the information will be passed on using IoT sensors or the smart sensors. Humidity or temperature sensor, pressure sensor, rain sensor, ranging sensor. When it starts raining, automatically the windows get closed. All these are automatic operations that take place using these smart sensors. And then ranging sensor, that is whether you will be hitting while taking reverse of the vehicle, whether you will be hitting an object or not, can be obtained. Then tilt sensor, whether the car is tilted, it may topple down. Torque sensor, steering wheel angle sensor, airbag sensor, wheel speed sensor, then fuel level sensor, windshield sensor for wiping purposes if it is dusty. So all these are various sensors. Now what I want to have an exercise for you people to enjoy is, let me know during next class. You can even send me a mail or through WhatsApp your answers regarding how many sensors or how many instruments are there in our mobile device. The weather is forecast on the mobile. Temperature is indicated, ambient temperature is indicated, pressure is indicated, humidity is indicated, so many other parameters. So it is an intelligent device, it is a palm top. So now, which are all the sensors, which are all the instruments the mobile device has? Kindly, the maximum number of sensors and instruments that are used in the mobile, which is a high density instrument, wonderful gadget. So I request you to kindly list the number of sensors and instruments in a mobile device. That will be the assignment 1 regarding the transducers that are used in mobiles. And you can also have a list of sensors in a car, sensors or instruments used in your houses and in hospitals. Which are the instruments and sensors used? You must be open for various applications where the sensors are used. So let me stop here. Thanks for participating in this online session of this smart sensor and instrumentation. Next, in the next class, I will be dealing with the basics of instrumentation. What is instrumentation and what are the characteristics of instruments and sensors which are helpful? How to design a transducer for a particular application. If I have to build a temperature transducer, what should be, I should understand the behavior, the characteristics, a static characteristic and dynamic characteristic of a sensor or a transducer or a pickup or a detector. Then suitably I have to design circuits to convert and then give a meaningful output which is measurable and which provides real information or information about the physical medium which the sensor is sensing, the parameter, So the measurand must be indicated accurately, precisely, reliably, and we have to look into how to design such devices. What is the engineering basic concepts involved? It's only a basic course, very simple and easy course, which you will enjoy and you will smash it in the exams and in the tests, nothing to worry. So this is just these two sessions, yesterday and today, are just introductory. And so I wish you a good day. Thank you. Bye. Is it okay? Will you please provide your attendance in chat box or whatever means you are giving to others? I will consolidate them and mark them in the attendance register that I have. Kindly help me in marking the attendance, because 81 of you are there. Kindly put your USN and name in your chat box. I will consolidate that into attendance. Okay, thank you. Bye.
Yes, sir.
मधून खद 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 ठीक आहे, ह्या शिलारस उखळत आहे, ठीक आहे, लावारस उखळत आहे. तर इथं का करते, ह्यात दणके देते, ह्यात दणके देते, ह्यात दणके देते, ह्यात दणके देते. दणके दिले का दणके दिले का इथं असं डेंबूर येते. मग हे डेंबूर मोठं मोठं होत जाते. हे डेंबूर मोठं मोठं झालं, चाललं मोठं मोठं, ह्या डेंबूर फुगते. आणि भाऊ डेंबूर फुगलं, खांडूक फुगलं कसं डग 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 करन ना, ते बी डग 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 खालतं पोसाईन त्याच्या. शिलारस आहे, खद्द 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 धड 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 धडकन असा धडकन रपकन स्फोट होते. रप्पा 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 याच्यातून धूळ धुके धुरके, ठीक आहे, धूळ धुरके धुके कार्बन ठीक आहे, धूळ धुरके धुके कार्बन मधून खद 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 धुरके धुके कार्बन डायऑक्साईड, नायट्रोजन डायऑक्साईड, सल्फर डायऑक्साईड, हा खद खद बाहेर निघते भाऊ. ह्या 2.5-3 किलोमीटर त्याचे धूळ धुके धुरके, हा आकाशात. कुठं? आकाशात. धूळ धुरके धुके सब, ठीक आहे, कुठं?